Writing chemical equations is a way of representing what happens in a chemical reaction in a very symbolic fashion. The basic format of any chemical equation is as follows. The arrow here represents a chemical change. In a chemical reaction, substances change into new substances. They do that through the breaking and making of chemical bonds. These substances here, to the left of the arrow, are called the reactants. These are substances that are combined together, come into contact with each other, or simply the ones that are present before the chemical change occurs. To the right side of the arrow, C and D represent chemical formulas of what are called products. These are the new substances that are created as a result of the chemical change. Now, in chemical reactions, you do not always have two reactants. You do not always have two products. However, if you have more than one reactant or more than one product, their chemical formulas are separated by a plus symbol. The plus symbol is analogous to the word and. So this would mean that reactant A and reactant B undergo chemical change to form product C and product D. These letters will be replaced by actual chemical formulas. So you will have to continue to use nomenclature skills to do formula writing. Now, the next important thing to know is that each reactant and each product has to be assigned one of four states of matter. The first state of matter, symbolized by lowercase s in parentheses, is solid. Reactants or products that are labeled with a S are metals, undissolved compounds, and precipitates. You may recall that a precipitate is a solid that is formed during a chemical reaction, usually from two dissolved compounds. So precipitates are always found as products. The next state of matter, shown by L in parentheses, is liquid. Now, this has very narrow applications. In fact, L is not all that common. If we do see L, it's usually when we're referring to liquid water, if water is an actual reactant or a product in the chemical reaction. It's also used if the element mercury or the element bromine is present in the chemical reaction, either as a reactant or a product. We'll talk about what the 2 in the bromine is in just a minute. So mercury and bromine are the two elements that are liquid at room temperature. And also, if a substance is described as being melted, it will receive the L designation. Next state of matter is G for gas. If you see that something is described as a vapor, that means it's in the gas phase. Also, there are some common gases that you should know. You should know that oxygen, the element, is normally a gas. Hydrogen, nitrogen, and of course, carbon dioxide. Okay, those are the substances that I expect you to know that unless it specifically otherwise states in the description of the chemical reaction, these will always receive a G. Okay, our fourth state of matter, not really a true state of matter, but it describes a lot of reactants and products in chemistry, and that is AQ. AQ stands for aqueous. Aqueous means watery. It's literally what the word aqueous means. So what types of reactants and products will have an AQ designation? This one is used when compounds are dissolved in water. It's very, very common in chemistry. A lot of chemical reactions will not occur if a substance is undissolved, but will occur if a substance has been dissolved in water. Okay. If you see the substance described as a solution, that's one way we describe a substance that's been dissolved in water. And acids. Acids always received the AQ designation. Okay, the next thing before we start writing an actual chemical equation out is the concept of the diatomic elements. You have to watch out for these. These are 7 non-metals. These always occur when they are elements, when they're not in a compound, when they are in their pure state as pairs of atoms, and they're always covalently bonded. So these are hydrogen, oxygen, and nitrogen. See? The word diatomic means 2. So rather than when we talk about hydrogen, that means that we have 2 hydrogen atoms bonded together. They always come as a pair. Hydrogen is always H2, O is always O2, N is always N2. And also the halogens are also diatomic. Okay, so that's fluorine, chloramine, bromine, and iodine. You have to be careful though. When these go into a compound, okay, the pair breaks up and each of the atoms will then go and bond with something else. For these compounds, the majority of the time they do not wish to be covalently bonded to another similar atom. They prefer to be bonded to something else in most cases. So hydrogen and oxygen especially are highly reactive. Fluorine is the most reactive element, followed by chlorine, and then bromine and iodine. Nitrogen is kind of interesting because nitrogen is diatomic, but it's triple bonded together. It's really hard. It takes a lot of energy to break that bond between 2 nitrogen atoms. So nitrogen tends to be relatively non-reactive. Alright, so let's go through an example here, a couple of examples of how to go from a description of a chemical reaction to a chemical equation. So here's our first example that says a strip of magnesium is placed into a beaker containing hydrochloric acid. Hydrogen gas bubbles are formed and black magnesium chloride is deposited on the bottom of the beaker. Okay, your first responsibility is going to be figuring out what are the chemicals that are in the reaction. Okay, so you read through here and you ask yourself where the elements and compounds are. Okay, magnesium, you know, is an element. Hydrochloric acid is an element, is a compound. Hydrogen's an element. Magnesium chloride is a compound. Okay, the next thing you have to ask yourself is which ones are the reactions and which ones are the products. In other words, which of these compounds will appear to the left of the arrow and which of these compounds will appear to the right of the arrow. Okay, if you read this through very carefully, it says the magnesium is put into a beaker with hydrochloric acid. Now remember that the reactants are the substances that are combined together and then undergo the chemical change. So magnesium is going to be a reactant and hydrochloric acid is going to be a reactant. So let's write the chemical formulas or symbols for each one of these. Magnesium is an element and its symbol is Mg. Hydrochloric acid, remember all acids begin with hydrogen. The prefix hydro indicates a binary acid, meaning it's hydrogen plus whatever element is here. Chloric means it's chlorine. It's going to be H and Cl. If you look on your periodic table, you'll notice that hydrogen is +1 and chlorine is -1. Okay, remember we said that if there are more than one product or more than one reactant, we're going to put a plus symbol in between them. Now we have the hydrogen and the magnesium chloride. The hydrogen is being formed, indicating that it's being created during the chemical reaction. So we're going to put hydrogen to the right here. H is for hydrogen. And then magnesium chloride. Okay, this is a simple ionic compound between magnesium and chlorine. If you look in your periodic table, you'll notice that magnesium is +2 for the oxidation number and chlorine is -1. So you're going to switch those, so it's going to become MgCl2. These are both products, so we're going to separate them with a plus symbol. Now we're going to go back and we're going to assign a state of matter to each one. Okay, the magnesium, it says it's a strip, and you should also know the magnesium is a metal. It's not part of a compound, so it must be just an elemental metal, which means it's going to be solid magnesium. Hydrochloric acid, we said that all acids are in the state of matter aqueous. That means that all acids are never pure compounds. They're always a little bit of water when we're talking about acids. It's just being dissolved, the acid and the water mixed together. Okay, hydrogen is described as a gas. We're going to put a G. And magnesium chloride is said is deposited on the bottom. Well, gases don't deposit on the bottom, and it doesn't make sense that a liquid is being deposited on the bottom. So this is also going to be a solid. Sometimes you have to draw your best guess from reading the description carefully. Okay, now the last thing before we move on is we're going to check for diatomic elements. We've got two elements in the reaction. We've got magnesium and hydrogen. They're not part of a compound. Magnesium is a metal, and diatomic elements are always nonmetals. So you look at hydrogen, and hydrogen is on your list. I highly suggest that you take your periodic table and with a highlighter, a marker, or a colored pencil, you outline or shade in the 7 diatomic elements somewhere on your periodic table, and then make a note for yourself that these are shaded or colored in because they are diatomic. Please note that there is no 2 on the H here. Yes, hydrogen's a diatomic element, but the diatomic rule only applies when the H is all by itself. When it's in a compound, like the H and the CLR, you just follow the regular nomenclature rules. We're not introducing anything that's changing the rules that you've previously learned. Alright, let's go through our second example. This says a solution of potassium dichromate is combined with a solution of iron 2 nitrate, forming a precipitate of iron 2 dichromate and leaving potassium nitrate dissolved in the water. So if you read through this, you should be able to identify potassium dichromate is a compound, iron 2 nitrate is a compound, iron 2 dichromate is a compound, and potassium nitrate is a compound. Okay, I'm going to draw my arrow, and it says that the potassium dichromate is combined with the iron 2 nitrate. So that means that these two substances are going to be my reactants. Okay, potassium, if we look at potassium is K. Dichromate, the ending ATE, indicates polyatomic ion. So if you look on the back of your table, you'll notice that the formula for dichromate is Cr2O7. Now let's look at the oxidation numbers. Potassium is 1, dichromate is -2, so that's K2, Cr2O7. Okay, iron 2, so that's Fe. Nitrate, again ATE, means look on the back of your periodic table and you'll see that nitrate is NO3. The Roman numeral means that the Fe is +2. The back of your periodic table shows you that nitrate is -1. So that means that I have to put the nitrate in parentheses and then I can add the 2. Okay, we're going to do the same thing here. This is iron and dichromate. You can kind of see what happened here. The iron and the potassium was bonded to dichromate, and then the iron bonded to the dichromate. The iron was bonded to the nitrate to start, and the potassium bonds to the nitrate at the end. They're switching places. Okay, so we have the Fe now is bonded to the Cr2O7. This is +2 and this is -2, so I don't need to change them. And the potassium nitrate, potassium is K, nitrate is NO3. This is +1 and -1, so they cancel each other out. Okay, lastly, we're going to assign them states of matter. Okay, this says solution, solution. That's your key word. Solutions mean that the substance is aqueous. This is also called a solution of iron nitrate. This is also aqueous. The iron dichromate, it says, is a precipitate. Remember that precipitates are solids that are formed in reactions. Okay, and it says potassium nitrate is dissolved in water. So it means this whole substance occurs in water, but the water doesn't appear anywhere in the reaction in this case because the water is not a reactant or product. The water is just there to keep these substances, keep these substances dissolved, and it also keeps the potassium nitrate dissolved after the reaction is over. Okay, so that is your order for doing things. Identify in the description of the reaction all of the compounds and elements, decide which one of them are reactants and go on the left side of the arrow, which one of them are products and go on the right side of the arrow. Write the equations very carefully, write the formulas very carefully. You have to practice your nomenclature skills to do well in this unit. Once you've got all of the formulas written out, go back and assign states of matter. Look for clues to the states of matter in the description. Okay, and the last thing that you would do would be to double check if you have any elements that are not in a compound. Check to see if they are diatomic. If they are, add a 2.